So let's get going. Good afternoon, everybody. Welcome to the San Francisco Bay Area Postgres Users Group meeting for February 2022. Lovely to see you all here. Really appreciate it. Just a few notes. Again, we are recording the session. And so if you choose to turn on your microphone and ask a question, you will be recorded. If you don't want to be recorded, you can send your question by chat to the organizers. We'll convey it to the speakers. Otherwise, if you're using the newest version of the app, which is what we recommend, down at the bottom, there's a React button with a hand, and one of the options is raising your hand. You can use that. We'll put you into the Q&A queue, question and answer queue, Q&A queue. Yes. Anyway, if you're using the older version, ping us on chat, and we'll add you to the queue that way. And let's see, other notes. If you have any technical issues, please send a chat message to the organizers. We'll do our best to help. And we talked about recording. Great. Okay. Today, I just want to thank United States PostgreSQL Association, aka PGUS. We're affiliated with them with sponsorship for our event, and we're very pleased to be part of their network. Full disclosure, I'm also the president of PGUS, but these are two separate things. we set up the affiliation before I joined PGUS. So, we're also sponsored by PostgreSQL Experts, PGX. Disclosure, that's my employer. Again, coincidental, these are really our separate things. Without further ado, I would like to introduce Joe Sciarrino and Jonathan Dance of Hydra. They are our speakers today, and they're going to be telling us all about Hydra for Postgres. Which one of you is going to be the primary presenter?
I'll kick it off, and then I guess I could hand over the presentation rights over to JD.
Okay, then I will make you the presenter. Yeah, to start.
Great.
Okay, so you should see presenter now.
I do.
Great. You're all set. I'm going to mute. Show is yours and Jonathan's.
Okay, great. Well, thanks everybody for joining. I'm Joe. Also joined here by my co-founder JD, Jonathan Dance. Let me know if you can see my screen.
Yes, we can. We see
I'm
the
going to
slide
go
and the slide.
Yeah.
Presenter view.
Perfect.
Okay, great. You're all set.
Awesome. Yeah, so thanks for joining. We're going to cover Hydra, which is a Postgres extension. We'll tell you a little bit about it. Let's get into what we'll actually be covering. First, we'll just do some quick intros, say who we are, then just like what is Hydra for Postgres? Why did we make this? JD is going to go through a demo. We'll do a brief comparison of Hydra against foreign data wrappers, because I'm sure that's very much on folks' mind. We'll talk about some of the technical design choices, why integrations are hard. So that'll be really kind of into the technical nitty-gritties. And then we'll open it up for questions. And hopefully some answers too. So hi again. Yep, I'm Joe. I'm that little screenshot on the left. We are a new Y Combinator-backed startup. I live in San Francisco. JD used to live in San Francisco. He recently moved to Austin, Texas this past year, as so many folks did, I think, during the pandemic. Just a little bit about me. Before starting Hydra, I was a PM at Microsoft Azure, specifically on the open source databases team and specifically working on Postgres. And I got there via Citus Data, which, if you're not familiar with Citus Data, is a multi-node scale-out version of Postgres. Before that, I was at Heroku. That's where JD and I met. JD was a director at Heroku for many years and briefly an engineering manager at Crunchy Data, which I'm sure you, the locals, will be familiar with. Okay, great. So, what is Hydra? Hydra is a Postgres extension that intelligently routes queries through Postgres to any other data store. you'll see how I cleverly wrote create extension any database. So what we're essentially doing is we make other data stores extensions of Postgres. So you can think of Hydra kind of like create extension Snowflake, create extension ClickHouse. The function is about creating, I'm getting some background noise. I'm not sure where that's from. Um, uh, from the perspective of an application or someone writing ad hoc queries, it's just regular Postgres. But we're making databases interoperable, kind of like interchangeable parts. So you just query Postgres and you don't need to learn how to work with any other data stores. Hydra just automatically pushes down computation to the right underlying place, regardless of, if it's, Snowflake or Redshift, doesn't particularly matter. So we're going to get into how Hydra query routing works soon. And the one other thing I wanted to point out about Hydra is we have this intelligent router you can see here in the diagram, but then there's also a little green arrow below, which is representing what we call the data bridge. And what that is we built this built-in data pipeline from Postgres to Snowflake that uses logical replication. So the idea is that once transactions get committed to Postgres, then they can move to the data warehouse without running some sort of external process. So it's super simple to set up. But we'll get into more of the technical specifics soon. Great. So, why do we make this? I think it comes from the belief that one database will not solve all of your problems. When the data size is smaller, Postgres is kind of like this sapling here on the left. It looks small, but you can bend it, you can contort it. Surprisingly, it's useful, but it's also adaptable and resilient to all kinds of different workload strains that you're going to put on it. Postgres at scale, kind of more like this mature tree, can be enterprise ready. So whatever that means, but it's battle tested. It's not going to fall over, trustworthy. But you can't really contort it and bend it like you could when it was the smaller, earlier state. And when I was working at like Heroku and Microsoft, I'd hear people commonly say like, "Okay, we're outgrowing Postgres." Well, not really. Maybe Postgres is doing exactly what it's good at. And your use case is trying to bend and twist Postgres in a direction that, it's not particularly meant for at the scale that you're at. So, that kind of leads to a nice conclusion that many people already have, which is, maybe just use the right tools for the right jobs. And we'll show in our demo how Postgres, already knows what's expensive and what queries are better routed to other type of data stores. So tree, like setting the tree analogy aside for a second, the right tool for the right job just practically means that you have to adopt additional databases to complement what you have with Postgres. Well, the problem with that is that adopting databases is hard. It requires application changes. It takes time to learn new tools. And that's pretty expensive busy work that, engineers don't actually like to do. So instead, we think that you should use Postgres ORMs and Postgres queries, and Hydra just will automatically return results from any database. So like no major changes are needed. And just lastly, on this last point here, we saw that companies want to merge workloads. So the most common one is like hybrid transactional and analytical processing. So, they wanted Postgres's transactional throughput, but needed, let's say, faster analytics. And the common use case for that is as soon as transactions are committed to Postgres, that they're available for real-time analytics. And it sounds easy, but at scale, it really isn't. So, instead of adopting new SQL data stores, we think you should just be able to coordinate Postgres with an analytical OLAP database from just a single endpoint to deliver that functionality. So I'm going to hand it over to JD, who will get into the demo and the technical design topics. Now, how can I hand over the presenter rights?
We'll need a little help.
I will do that now.
Yes.
Okay, perfect.
JD, make presenter. Okay, so JD, you are now the presenter, and I'm going to turn my mic off again.
Okay. Why am I not, of course, not seeing the right window?
I think there's another tab that's called Applications.
Yeah.
Yeah.
But what is this doing? That's that window. That's what I'm supposed to say. Why doesn't it want to play along? I did test this before at the meeting too, and it worked fine. All right, I'm just going to close that. Ah, there it is.
Okay, found it.
Yeah, I won't be able to see my notes, but, and I need to go backwards. Where are we? Oh my goodness. Okay, that was fun. Hi. So yeah, my name is Jonathan Dance. As you've no doubt figured out already, I go by JD. And on the internet, my handle is Whoopata. And I'm the CTO at Hydra, which has been super fun. And yeah, so the first thing, just going to kind of explain a little bit of how do you use Hydra? Kind of our documentation in a nutshell here. So basically you're starting with Postgres and you install, if you were to get it from us, like a setup instance, it would already be installed, but alternatively you would create extension Hydra. And the first thing we need is a connection to your external data store. And we started with Snowflake. So in my examples here, I'm going to use Snowflake. So you set up your Snowflake connection, you kind of tell us your credentials, and you need to tell us what data is replicated between Postgres and Snowflake. So that's all in our documentation. It's not too bad. So now kind of we've set it up. Our next step is we actually want to do some querying. So what you do now is you set the query engine to how you want it to work. And there's basically three options. You can say query Postgres, which will basically work just as if Hydra wasn't there. You can set it to Snowflake, which will send queries to Snowflake as long as Hydra believes your data will exist there. And the third option is intelligent, which will route queries between Snowflake and Postgres based on this cost threshold, which I mentioned here. So there's an adjustable cost threshold, which allows you to say, like, how expensive should a query be to route to Snowflake? So basically, the default is send it to Postgres, and if it's too expensive, send it to Snowflake. Once you've done that, you query as usual, and this is kind of the beauty of it, is it kind of just works, and you don't have to think about it beyond sort of like those settings I mentioned. We also have a function called run on Snowflake, which you can use to query Snowflake directly. We call that the manual router, but this is the implementation of it. And this would allow you to send a query to Snowflake that is either not Postgres compliant. So if there's some Snowflake thing that won't parse through Postgres, or you could also use it to run modification queries. You could run create table. You could insert data this way. You can also use it to query Postgres and combine data together from multiple data sources. All right, so if that didn't make any sense, I will show you instead. Oh, okay, this is fun. More screen sharing stuff. Ah, I see the problem from before. It's paginated. That's why I was having trouble the first time. Okay, so what I have, is this big enough for people to see? I guess Joe can confirm most easily.
Yeah, I think so.
Okay. Yeah,
At least for me.
It's nice and big. It's displaying, and yeah.
Awesome. So I'm just sitting here inside pSQL on our demo server actually, which is a not really a big machine. It's a M5 large on AWS. And yeah, I'll just kind of show you around. I think I've already turned timing on actually. Yeah, so there's it off, it's on. So we'll get some performance data. You can see, I don't know why I'm typing because I was going to do copy paste. You can see all the tables that we've already set up to query between Snowflake and Postgres. This is our configuration table. So, it's just a normal Postgres table. And our schema locally here is the TPCDS schema, which if you're not familiar with is this standard for doing performance testing. And I just realized these tables are not super readable, but basically it doesn't really matter what the schema is per se, but we have about a gigabyte of data here. And so if we do set Hydra query engine to Postgres, we can do a count of our inventory table, which is the largest table in this data set. Oh. See, should always copy paste. So there's 11.7 million rows in this table. It took about 600 milliseconds. And this same schema is in, nope, that's not right. Copy paste is hard, guys. That's why we're all professional copy paste developers, right? So we query that same thing from Snowflake. Of course, demo gods. What is wrong? Why? Whenever you do a live demo, you should never do a live demo. That's the rule. What? I did that. What is happening? I'm really confused. Why isn't it querying Snowflake? It's misbehaving. This just shows that we are a young company and sometimes there are bugs. I'm going to see what happens with the intelligent router just for good measure. So, well, anyway, so what that was supposed to show is that there's about 1.3 billion records sitting in Snowflake. I'm not sure why. I tested this yesterday, of course, and now it doesn't want to play along. But yeah, so we have this much bigger data set in Snowflake. So we have a 1 gigabyte data store in Postgres, and we have a 10 terabyte data store in Snowflake. So the difference here is obviously really high. So what I'm going to do is, yeah, we did that already. I'm going to set a cost threshold and see if it wants to query Snowflake now or not. No, it really doesn't want to play along. I'm not sure why it's doing this. This is a new one. It actually is maybe this might be it. It's acting like it's, there we go. Okay, that's weird. I've never needed to do that before. It shouldn't have to do that, so that is a bug. Anyway, okay, we're back on track. So you can now see there's 13, this is a really big number, guys, 1.3 billion records, okay. And this query executed on Snowflake because it's above the cost threshold to send it to Postgres. And you can see it actually executed in 400 milliseconds. I don't know how Snowflake counts that number of rows in 400 milliseconds, but yeah, I don't ask these kinds of questions. That's their magic. So we're in intelligent routing mode right now, so you can also query something simple like give me 5 records, and you can see it's routing it locally. So this took 300 microseconds, I think, 300.3 milliseconds. So just a little bit more, let's play with it just a little bit more. If we want to run, I tell you, copy paste is a lot harder than it seems. If we want to run a count query, this query gets routed to Snowflake, and it executed in 250 milliseconds. But this query doesn't seem too complicated, right? It's just a count on one thing. But the problem is, if we look at the table, we don't have an index on that column. So that's why it's getting routed to Snowflake. The cost is too high. So if you were to compare that, but we do have this primary key here. So let's change the query just a little bit and use that primary key. And we can see 5 milliseconds routed to Postgres because that cost is really low. And if you were to, you could add a second key here, which is going to execute even faster, and it's going to run it locally. So that's kind of the picture here is expensive queries sent to Snowflake, cheap queries sent to Postgres. All right, I'm going to go back to the presentation now. All right, so you may already have some guesses as to why not foreign data wrappers. But yeah, you might be asking yourself, this is pretty familiar stuff in a way. Like, this seems like I could implement this with foreign data wrappers. So why not use foreign data wrappers? Well, foreign data wrappers we found are just considerably slower than local tables. And what I mean here is that we were surprised to find that even testing foreign data wrappers when you talk to a local database, meaning there's no latency, we did not get very good performance. So queries can take considerably longer depending on the query. And I'll show you some examples on the next slide. And what we wanted to do is really wanted to harness the power of the other data stores. And we were worried that in order to do that effectively, we couldn't use foreign data wrappers. We wanted to be able to say, okay, this query is going to completely get pushed down in its entirety to the external data store. And that's especially important when you're talking about a query that is going to go to something like Snowflake, where there might be many terabytes of data. A 10x slowdown could mean the difference between a 5-second query and a 50-second query, or something like that. Or hopefully it's a 500 millisecond query, even better. So this is just a contrived example. It uses the same schema that we were just using, but it's just some local testing that we did, and found that this query ran against a foreign data wrapper in 12 seconds, and was able to get that a little quicker by turning on the remote estimate, which gets you a better query plan down to about 3 seconds. But if I ran the query on the database itself, it ran in about 2 seconds. So this is the Postgres foreign data wrapper, which at least my assumption is that this foreign data wrapper is probably about as good as it's going to get. So yeah, that's why we went in the direction we did. And so yeah, I want to talk a little bit about why is Hydra a Postgres extension? So the really neat thing about Postgres really is that you can extend it. Postgres extensions are amazing. And you can hook into any part of Postgres you want. And I have a few links here. We can share the slides after the talk. I don't want to go into an in-depth talk about Postgres hooks, but you can hook into all kinds of different parts of Postgres. And it's covered in the Postgres docs as well. And the main one that we use is executor run hook. So this is basically the hook that is called when a query is being executed. And so we can act kind of like a middleware and say, okay, how should this query be executed? We can look at the query plan, we can look at the cost estimate, we can look at how the customer, the user has configured the database, and we can send the query to the ideal place. And in addition, we have access to the Postgres internals, so we can do things like reading the schema of the tables that you have to present results using that schema. Return results as if you were querying Postgres itself, and that's really only possible in this way. Well, I'm sure there's other ways to do it, to be fair, but this is the most efficient way to do it, right? So like you're inside Postgres and there's no latency to any of these services. You can directly access Postgres. In the future, I think we will plan to use other hooks. So we don't have an explain plan right now. If you run explain, it will give you the Postgres explain, but it doesn't give you like a Hydra explain. So hope to do that in the future. We might hook into the planner in order to, not actually sure, we'll see. And the executor start hook, I think we might use to, if that's the right one, to like possibly modify queries if needed. So the other thing that that's great about Postgres extensions is they're fun to develop, but they're also kind of scary. You definitely are trusting us to not change the results of your query, but also just we can't mess up, and that's definitely been something that has been it definitely makes development a little trickier. I think I have on the next page, like, yeah, you can and will need to call Postgres functions to build something like Hydra. And some of the functions that we call are documented, but many are not. And at least not in like a public facing way. So it requires digging through source code and looking at other extensions. And yeah, you're writing C code that talks to Postgres, and you're going to be debugging seg faults, which is not fun. We don't want to be crashing your Postgres database, and definitely take a lot of effort to try to avoid that. Which segues me nicely into my next topic, which talks a little bit about how we integrated Snowflake. And what we chose to do, well, first we were looking around and we were really struggling to find a good way to do this. And there's, Postgres is written in C, Postgres extensions are written in C, and we really needed a C driver. But the main one out there was libsnowflake client, but it's under active development, had a lot of dependencies, very hard to get it to build. It was just kind of too much of a moving target. And thinking to ourselves, all right, how are we going to solve this problem? So we decided to write our own. And in order to do that, we would need quite a bit of stuff. So, basically libraries and such. So we decided to do it in Rust. So Rust kind of offers some advantages, especially as I mentioned, like some of those problems working with C, we now have a much safer language to work in and something that's much easier to debug where we're not going to run into seg faults. So if you ever think about writing a Postgres extension, you might consider writing it in Rust or working with Rust from your Postgres extension, which is actually what we did. Our Postgres extension is a mix of C and Rust. And so that's the first thing that we needed from Rust, right, was something that could talk directly to C. We also were able to use a lot of libraries in the Rust ecosystem to make it easier to build. It's a lot safer, which basically means that Rust goes through a lot of effort to make sure that you won't seg fault your code. You won't access memory that doesn't exist. Unfortunately, it's safe except for unsafe code, which I'll get to on the next slide. It's very fast. It's compiled to machine code. It's comparable to C in most cases. It has a really great compiler and great tools, which in my opinion, is why people love it so much. And there's a really neat project where you can build entire Postgres extensions in Rust, which I linked to here from ZomboDB. But there are some disadvantages of Rust. It does have a pretty steep learning curve. It's, I think, the first month or so that I started working on this, I did not get very far. It took me some time. And it's also not particularly easy to talk to C from Rust or vice versa. You have to do a fair bit of data manipulation to get your data to move in and out of Rust. And the code that does that will be unsafe, which does open you up to some possible seg faults. So those are definitely some rough edges. And it's not a big concern, but because Rust, most things that you end up using in Rust are not shared libraries, which means like, let's say, for instance, you want to make a web request, you're probably not going to use something like curl exposed via a library. It's just going to be like HTTP re-implemented in Rust. And so that means that everything kind of gets compiled into your binary. And that means you're going to have some longer compile times and your binaries are going to be a little bit larger. So yeah, I would definitely give Rust a chance if you have time. It's great if you can spend time to learn it. I think it's like the developer's favorite language for a reason. But expect some hiccups if you're going to interact with C. But overall, I'm really glad that we did it. And it was really fun to learn a new language as part of building Hydra. And that's as much as I'll talk about Rust without talking about Postgres. But I did talk about Postgres too, right? Rust and Postgres together, I think, could be an interesting future. So yeah, that's it. Thank you very much. And we'll open things up to questions. I think there's already some in chat.
Yeah, we actually have a number of them. So the first one just says, explain plan, question mark.
I think that was during the hiccup I was having.
Okay, great. Okay.
And actually, if we could even ask a question first. So we started with obviously Postgres and Snowflake. Would folks mind writing in the chat what other databases they would be interested in if Hydra supported, ClickHouse or DynamoDB or something like that? I'd be kind of curious to hear what people have to say, and then I'd love to dive into some of these questions.
Cool. Okay, everybody, have a good time in the chat with your feedback on that. So our first chat question, can Hydra choose a Snowflake warehouse based on service conditions, i.e. have a particular query go to a different warehouse based on the Snowflake warehouse load?
It certainly does not do that right now. But I think that, our cost thresholds based approach is definitely kind of the tip of the iceberg for this. We have quite a few ideas actually about how to make the intelligent router more intelligent. The Snowflake, I've not really seen much information about how Snowflake load gets returned to us, but it's definitely an interesting idea. I think like one of the things that I was thinking about was being able to route queries based on like kind of raw performance numbers. So like, just which query is like, if you were to execute the same query on both engines, which is faster, and then using that data to feed itself, you could kind of say that's an ML-based approach, but not quite full ML. But yeah, kind of like learning from itself. And so I think like in that case, you could potentially see where the data you're getting back would reflect the performance of each system and how much load it's under. And so that would like help drive that.
Great. Okay. Next one, Snowflake can be expensive, especially when you have many applications connecting to different warehouses. Have you considered helping customers reduce this cost by having Hydra direct workloads to less expensive warehouses?
Yeah, I mean, I think that this maybe is maybe the answer here is sort of in Joe's question to the audience. We definitely want to support more than just Snowflake. So if you're finding Snowflake is just too expensive, we want to support Redshift and ClickHouse, and as well as just help with integration stories around potentially talking to other databases like MongoDB or MySQL or things like that.
Okay. Next up, do you have any tools to help customers move apps which currently talk to Snowflake move to Hydra without rewriting their Snowflake SQL, e.g. a Hydra JDBC DBI driver or something?
I'm not sure I quite follow here. Oh, I see. I think what you mean, because yeah, Snowflake uses JDBC. So Hydra is just Postgres. So I think you could use Postgres JDBC driver. But you're right that the expectation that we have at this time is that the SQL is Postgres compliant. We are looking to support these kind of use cases where whether a query needs to be rewritten coming in to Postgres or a query needs to be rewritten going out from Postgres to another data store. Like MongoDB is completely different, right? So yeah, in those kind of cases, yeah, we could definitely build something in the future, but no, we don't have any tools yet.
Great. Okay. Next one down. Does Hydra support routing parts of a query to remote? Say, in a multi-table join, one relation is local and the other in Snowflake. Can it send only the relevant part of the query to remote?
Yes, this is an excellent question. We do not support that today unless you use the manual router. So because right now the query has to be sent wholesale to one data store or the other. Again, our product is very young, and we hope to develop it further in lots of interesting ways. But yeah, I do have an example query of this in our documentation where you use the manual router function to query Snowflake and join it with a Postgres function. So it is possible to do that, but it's not something where we can, at least not yet, decompose the query into like two pieces.
Okay. Next, was your example of data in both databases, PG and Snowflake, contrived? If rows 1 to 100 are in Postgres and rows 1 to 1000 are in Snowflake, if you want row 101, you have to go to Snowflake in order to receive it, regardless of performance.
I mean, yes, it's a contrived example, but I think in my example, obviously I talked about how there's a 1 gigabyte of data locally and 10 terabytes in Snowflake, right? So obviously there's a lot of data missing from Postgres locally. So if there's some expectation here that if you were to actually set up your database that way, you would need to know as the querier operator, implementer, where your data is living and what data you have locally versus remotely in Snowflake. I think that this is actually a pretty interesting like real world use case actually. So you could imagine that my computer is doing something weird. Okay, it's back. Oh, isn't remote fun? Okay. Can you guys hear me?
Yes, you're back.
Okay, good. It just like went black for a few seconds.
Nope, you're there.
Yeah, so you could imagine that a possible use case is you only store the most recent month or week in Postgres, and your historical data is in Snowflake. And the intelligent router right now is doing cost-based analysis, so it wouldn't necessarily help you with that decision, but you could also imagine that any of your analytical queries, if you store enough data locally, like your analytical queries are going to be sent to Snowflake anyway. So it's really only if you made your local table really small would it go to the wrong place. But I think that the better option to make sure your data comes back the way you expect is that you might explicitly ask Snowflake in for your analytical queries in that case.
Okay. I don't see any other. Oh, here we go. I like the idea of using this to enable quick, low-cost development with Hydra without using Snowflake. So, yay. So are there other questions? I don't see any hands up.
One thing is, I think Snowflake, it can probably be expensive. I'm guessing mostly because they don't transparently share their pricing on their website. So that's generally a good bet that it's expensive. But I would say that they do offer a 30-day free trial. And we certainly have used that. So maybe you should do that too, if you're kind of curious about it. But to the point, we certainly will support Redshift and probably, BigQuery and a few other data warehouses soon. We had some good suggestions here of different integrations that we could support. Someone said DB2, kidding. But I do think there's something interesting there. Yeah, I think there's something interesting there, though, even though it was a joke, because there may be, maybe not for this modern crowd, but there are big enterprise companies where there can be antiquated databases, that people don't really know how to use. And if you connected it via Hydra, then you could, use Postgres queries to access those stores where people retired and nobody knows how to work with, Sybase or something anymore. So just an example, but yeah.
We have one. We have another question. What do you use to mirror the Postgres data to Snowflake?
Yeah, so that's exactly what our data bridge is designed to solve. The easiest use case, that at least for this hybrid transactional and analytical workload, is to have your data synced basically in real time, and that's what the data bridge does. And yeah, it's built on top of logical replication. You are not obliged to use it. If you have an existing data pipeline, that's also an option.
Okay, great. And checking one more time, I don't see any raised hands. We've covered everything in chat. So Joe and JD, thank you both so much for giving us your time this afternoon. Really appreciate it.
No problem.
And everybody says, hey, good luck.
Thank
Always
you.
nice. And some thank yous coming up, so yay. Really appreciate it. That was interesting. And I love the name. I gotta say, it's sea monsters of all kinds, right? What's not to like?
Thank you. Obviously, we're built on Postgres, so this is our number one absolute favorite group of people to be talking with. So thanks for letting us share with you all. And yeah, if you find us on Twitter or something, give us a shout out. We'd love to get more people thinking about how they can use Postgres, compliant SQL over all other data stores. So yeah, thanks.
Great. No, thank you both. And so just a few wrap-up items. Our next PUG is March 9. We'd like a speaker. Perhaps it's you. Perhaps you have someone that you can suggest. So drop us a note and we'll get something on calendar. Always interested. Presentation doesn't have to be, an in-depth thing. We particularly are happy to hear from first-time speakers. This is a great way to practice your presentation, so let us know what you'd like to talk about. Upcoming February 15, the Chicago group is hosting Improving PG-Based Backup in version 15 and beyond with Robert Haas. So you can look that up if you're interested. CMH on February 22nd is presenting Demystifying Kubernetes Operators for the PostgreSQL DBA with Adam Wright. So a couple new interesting things coming up. Again, thank you to our speakers. Thank you to our members for coming. And we will see you all in March. Take care. Bye.